Hi, this is Dr. T.H. Culhane from PORPOISE Robotics.
And I'm Jerry Garcia.
We are trying out new concepts here for the pipeline from Sea Perch to the Roboboat Robo-Sub competitions. And the concept here is to use Brent Spencer from Motion Picture Marine's Sea Sparrow, which we've made a replica of in miniature for the project, and dock the sea perch in. And here's how the basic concept works. The sea perch, which many middle schoolers know and have been delighted by for years, has 3 motors, and generally it's controlled by a manual controller. However, we're now taking the hands-off approach, and we're going to let the human being operate remotely with their computer using an XP shield and an Arduino board and an Adafruit motor shield. So that what's going to happen is, instead of using the hand controller, and we have the example of that right here, this is the usual controller for the sea perch motors, left and right, backwards, forward, and up and down. Instead, those commands are going to be sent from the computer serial monitor from the Arduino sketch via this XP transceiver, and wirelessly to the boat on the water. It'll be received by this XP transceiver here, and then the commands will tell the motors which way to turn depending on which keys you press. If you press F, it goes forward. If you press B, it goes backwards. L, left. R, right. U, up. D, down. It'll control all these motors using this motor shield here. How we're powering this motor shield is with an 11.1 volt and 2.2 amp lithium polymer battery, very lightweight, so it can sit on the craft. And that's powering the motor shield. The Arduino, meanwhile, is being controlled by, or being powered by, this nickel metal hydride 9.6 volt, 2.1 amp battery pack. So you have 2 battery packs per system. And then it's going through a standard telephone jack, and the normal Sea Perch Cat5 cable, the Ethernet cable, is just being plugged into that instead of into the control box as it used to be. It used to go into here. And now we're not going into here anymore, we're just taking it out and plugging it right into here. Then we can control the sea perch. Another thing that this Adafruit motor shield will enable us to do is to connect these robotic claws with their servos right here on these pins up here. That's one of the advantages of the Adafruit motor shield, that it does have the ability to control 4 motors and several servos. So we're putting the servo here. And then it will be able to grab the sea perch and hold it in place with these robotic claws so that the boat, the Sea Sparrow, can take the sea perch out to its destination. And when it's at its destination, the claws will be triggered by a command from the remote keyboard off on shore to open up, and then the students will turn on the down motor, make the boat dive, then turn on the left and right motors and pilot the boat, which has, pilot the sea perch, which has a camera so they can see where they're going. Meanwhile, besides having a camera, the Sea Perch has the Sea Perch Sensor Suite by MIT. And the Sea Perch Sensor Suite by MIT has an Arduino board. This one the students built themselves. It's a SparkFun Arduino clone. And mounted on top as a shield is the Sea Perch Sensor Suite, which measures temperature, salinity, depth, and turbidity, light. So by having those sensors and recording them on an SD card here, as the sea perch is doing its mission underwater, it's gathering all this data and time-stamping that data. And then when they recover the sea perch, they can upload that data to Google Earth's digital ocean. So they're doing real science with this. So once again, the Sea Perch has a camera so they can see how to pilot it, and the MIT Sea Perch Sensor Suite to gather real scientific data to contribute to the collective data collection effort that we're doing around the world. So it's not just a toy. So that's going to be controlled by the remote XP via this sandwich, if you like, of Arduino board, XP, and motor shield. That's one part of the system. The other thing is, how do we get the sea perch out to the place where it's going to do its mission? The boat needs to be able to move. Now, if you are just starting out and you don't want to invest a lot of money in it, the sea perch has motors. So once the robotic claws have grabbed the sea perch and it's set, you can just pilot the whole boat by turning on these motors and then drive the craft. But these are weak motors, so they're not going to go very fast. The next step is to add more powerful motors, and we were testing them before here, and they are on the boat itself, controlled by, yes, another Arduino board and another more powerful motor shield, this one able to handle up to 2 amps per channel, whereas the Adafruit board can only handle 1 amp per channel. These handle 2, so that can power these more powerful boat motors. It does cost having one more Arduino board and one more motor controller, and that's $30 there and about $30 there, so another $60 to be able to pilot the boat. But we want the boat to be autonomous. We don't want the boat to be controlled by the students. The Sea Perch, yes, it's going underwater. It can't really do much logic underwater. But we can give the brain to boat, and the Arduino is a perfect little brain hooked up to a ping sensor, or maybe several of them, which will detect the distance. It uses sonar, just like a real porpoise would. And if it comes toward an object, like a rocky shoal or a wall or a boat, then it will turn the motors backwards, stop, turn left, and then try to continue. If it encounters another object, the ping sensor will react. It will tell the boat, go back, turn, and keep going. And so that puts intelligence into the boat, so the boat can be an autonomous craft. We're also going to put on the boat a PIR sensor, which is an infrared sensor that can detect heat and motion. You see these in motion detectors all the time in people's garages. They turn on lights. This will also detect if, for example, a shark comes up suddenly, and we can then have it autonomously avoid something that's moving. So the motion detector's on there. And then the last thing we'll put on is we'll put on a GPS sensor. And the GPS will tell us exactly where the craft is, and that way we can tell the boat automatically, go to where the Titanic is, go to where the treasure is. And the boat itself will look for those GPS latitude, longitude coordinates, find it, turn off the motors, and then initiate the action where the students will drop the Sea Perch submarine to go down and discover the Titanic, or find the sunken treasure, or cap an oil well that's spilling, or clean up toxic waste, whatever the mission happens to be. So that's the basic idea of the craft. As you can see, they're all built of the same materials. The Sea Perch was brilliantly conceived to use PVC plumbing pipe and film canisters and little motors with propellers. In a similar vein, the Sea Sparrow, modeled after Brent Spencer's real craft, is made on the junior level using the same PVC pipe as its endoskeleton. It's biomimicry in action. And then the skin on it is just 3-ply of this corrugated plastic that's very inexpensive. And we do it like plywood. We put it cross-hatched to give it structural strength so it can handle the weight of the batteries and the boards. And anybody can build it. The pontoons are made out of plastic bottles, water bottles. There's also a whole bunch in the nose to keep it afloat, if you come over here and see under there. So it is a craft that anybody can make. Anybody can get into maritime robotics this way. Depending on how much they invest, they can go all the way to having a Terminator type of robot. But at the very beginning, the basic Sea Perch can run most of the craft. Thanks.